Greetings, Commander King here with another ACT mission for you specialists. Alright, so our first mission from the ACT is to fertilize one plot of farmland on Mars. So the Alliance requests us to create 125.0 liters of ammonia gas. We're going to assume that it's STP on Mars, though that might or might not be a great assumption. And to create ammonia, we're going to use something called the Haber process, which uses nitrogen gas mixed with hydrogen gas. And we want to know, okay, how many liters of H2 and N2 will I need to create that ammonia? All right. So before I delve into this, ammonia is kind of a key resource that we create in order to create more fertilizer. And fertilizer is important because we want to grow crops effectively. Without fertilizer, soils would actually lack a lot of the nitrogen that plants need to grow. So even though it seems very simple and something we take for granted, producing ammonia is actually a very difficult task, and it was very difficult until this guy called Fritz Haber. He came in and we'll call him Mr. Fritz here, or just Fritz. Yeah, Fritz. He came in and he found this Haber process. And through the process, we can now make ammonia gas very easily and use that to create fertilizer. So that's pretty cool. So let's take a look at the problem. And we know we're creating NH3 from the problem, right? We're trying to create ammonia. So we know we are creating ammonia gas. All right, so that's what we want to do. And what we have here is we're mixing nitrogen gas and we're adding hydrogen gas to it. So it seems like we mix nitrogen gas, we're mixing it with hydrogen gas. They're going to react somehow to form this NH3. Okay, great. So just looking at this, I'm trying to think, all right, I've got my chemical equation. Let me just fill in with the state of matter there. And now I'm thinking, is this balanced? Because I want to know how much of each of these reactants I need to create that NH3. Well, I need two nitrogens here, and I only got one here. So I'm going to balance that out by putting the two here. I've got two nitrogens on both sides now. But now I've got 6 hydrogens here. I've only got 2 here, so let's put that 3 there. And now it seems I got 2 nitrogen here, 2 nitrogen here, 6 hydrogen here, and 6 hydrogen here. So I've completed the first step that I need is to figure out the chemical reaction, which tells me how much of each molecule I need to do this problem. Okay, so let's get ready for the next part. All right, so let's try to figure this out. I know I've got 3 H2 molecules as a gas, and I'm adding N2 as a gas, and I'm trying to make NH3, right? So this is going to be 2 molecules of NH3, and I'm going to try to use this box method to figure out, and really the box is just a guide for me, okay? So I know I have an amount to start with, and the amount that I need to create is 125.0 liters of NH3 gas. And I know what I'm trying to figure out, so I'm going to start this because this is where I'm starting. So this is just to help me keep track. And I know I'm trying to get to the liters of N2 and I'm going to get to the liters of H2. That's what I want to figure out. Okay, but I know that I can't directly, I don't know how many liters of N2 it takes to produce 2 liters of NH3, right? Or I don't know how many liters of N2 it takes to produce 1 liter of NH3. I don't know the exact ratios. But what I do know is that to create 2 moles of NH3, I need 1 mole of N2 and 3 moles of H2. And I know to create 4 moles of NH3, I would need 2 moles of N2 and 6 moles of H2. So I have that going for me. So if I could just get into moles, if I could convert to moles the amount of NH3 that I need to produce, then I can quickly convert to N2 and H2, and then from there I can convert to liters. So this is just to help me picture this. All right, so I'm going to call this step 1. All right, where I'm trying to go from the liters of NH3 to the moles of NH3. And to do that, of course, I need a conversion. I need to think about how many liters are there in a mole or more than 1 mole of NH3. And at STP, we know that there are 22.4 liters per 1 mole. So in other words, 1 mole of something takes up 22.4 liters of space. So I think we're ready to do this conversion, where we're going from the liters of NH3 to the moles of NH3. All right, so I'm starting with 125.0 liters of NH3. And I know I'm trying to convert to moles, right? Moles of NH3. So that's good. And I have a conversion. Well, I know I need to cancel my liters of NH3. So those are going to cancel. and I know I need to go to the moles of NH3. So I'm going to put the moles of NH3 on top, and I say, okay, even though this is 22 over 1, but I know the 22.4 is with the liters, the 1's with the moles. So again, I'm going to take my 22.4, put it with the liters, and put the 1 mole there, and now I can quickly calculate that. So I'm going to pull up my calculator here, my handy dandy calculator, 125 divided by 22.4, and that gets me about 5.58 moles. All right, so thank you, calculator. That gives me about 5.58 moles, okay, and 3 sig figs because of the conversion there. 5.58 moles of NH3. Okay, so I've got that, right? I've got that, and now I'm thinking, okay, well, to make 2 moles of this, I need 1 mole of N2. So to make 5.58, okay, well, we always need half the amount of N2 as the NH3, so I'm just going to think, okay, I need half as much, so I'm going to multiply by 1/2, and that's going to give me, what, 2.76, I believe, 2.76 moles of N2. Okay, so I know I need 2.76 moles of N2, and I can just think of it this way. All right, well, I'm trying to go this way, and I know for every 2 moles of NH3, I'm going to need 3 moles of H2, because for every 2 here, you have 3 here. So I'm going to multiply by 3/2, and this is just really a simple molar conversion. I can think of it as multiplying by 3 moles of H2, because that's what I'm trying to get to, and I have currently 2 moles of NH3. So I can do that out. So let's call this step 2. I know it's getting a little crowded in here, but let's call this step 2. And in step 2, I'm taking 5.58 moles of NH3, and I'm trying to figure out, well, how many moles of H2 do I need to create that many moles of NH3? Well, I know I need to cancel my moles of NH3, and I know I need to convert to my moles of H2. And so it seems like, well, the chemical equation tells me the ratio here. It's a 3-to-2 ratio. So for 3 moles of H2, for every 3 moles of H2, sorry, I'll make 2 moles of NH3. And if I do that, I'm going to take out my handy dandy calculator again, pull it over here, and take 5.58 times 3, and then divide by 2, and that's going to give me 8.37 moles. Now just to check, all right, to see if this makes sense, I know for 3 of these, I make 2 of these. So I should have more moles here than more moles here, and that checks out. And for every 2 I make, I only need 1 of these, so this should be half of that, and it does. All right, so that's a quick way to check. And now finally, I just have to convert back up. I know I need a conversion to go from moles to liters, but we know at STP, regardless of the element, regardless of the molecule, it's always 22.4 liters per mole, and I'll call this step 3, and I'll leave N2 out because I think you can calculate that. But then we have 37 moles of H2, and I'm trying to figure out, okay, how many liters of H2 I can make, so I'm going to put that there. I know I'm canceling my moles of H2. I'm going to let the units guide me. I'm trying to get to liters of H2, and I know that there are 22.4 liters of H2 per 1 mole of H2. So let's do one calculation here. 8.37 times 22.4, and that's going to give me 187.488, or 187 liters of H2 given my sig figs. And if I wanted to do the same calculation, it's just like this. So I know my setup is right, and so I'm just going to take 2.76 times 22.4, and that's going to give me, oh, did I make a mistake? Yeah. 2.76 times 22.4, and that's going to give me 61.8 liters. So 61.8 liters. Okay, so to create 125 liters of NH3, I'm going to need 187 liters of H2 and 61.8 liters of N2, and that's going to allow me to create this ammonia. Okay. Good luck with your future problems. I hope this was helpful.